So students, essentially this is the experiment, this is the track, and the methods describe how I did it when I theoretically collected my data. But essentially all that's happening is, boom, collision. All right, now watch the actual collision, right? Because if there are any problems with it, that's going to cause some error. If there are any problems with the way I'm propelling the marbles or anything like that, and I would do 5 for each set of collisions. And obviously, if the marbles move out of frame during the 0.2 seconds I'm trying to calculate their velocity, I'm going to have to redo that trial, and I would, of course, redo that in an experiment. Okie dokie. So now we've seen the collision. You've got the methods that explains how the data is taken using an iPhone, okay? But when you're looking at that Google Sheet, I want you to think about what each of these numbers is, right? So, right, you're looking at these marbles, okay, and they're coming towards each other, right? And the thing that we're keeping the same this time isn't distance, right? But it's the amount of time that we're watching the marble, right? So as these marbles head towards each other, it's funny, there's a slope here, right? As the marbles run towards each other, okay, marble 1 and marble 2, they each have a velocity and they each have a mass. Boom, okay? And as they move away from each other, marble 1 is going to move a distance in that amount of time, which is 0.2 seconds for each trial, and marble 2 is going to move a distance for that amount of time. All right? Now, those distances will be variable between collisions. So, when you go here to the data sheet, can you even see this thing? Right? You're inventing a distance. The time, not so invented, right? You got to look at the methods section to see what the times are. So distance 1 and distance 2 would refer to marble 1 and marble 2. Time 1 and time 2 would refer to marble 1 and marble 2. And velocity 1 and velocity 2 would refer to marble 1 and marble 2 headed towards each other. Okay? So you're going to have a momentum before the collision, and you're going to have a total momentum after the collision. Now, what you're going to try to do here is, after you come up with a hypothesis, right, you're going to collect a set of data that refutes it and a set of data that supports it. I'm sorry, I said collect. I mean make up. You're just going to make up data, which is great. Use meters as your distance unit and use seconds as your time unit, although that'll be clear from the methods. And then that way your velocities will be in meters per second, of course, and your momentums will then be in Newton seconds. Cool. So, the idea here is that momentum is conserved in a collision, especially right before and right after it. So, we've provided you with a data sheet to put your fake data in, and we've provided you for the parts of the lab report that you're not going to write. In the next 2 weeks, the total amount of stuff that you're going to do here is you're going to write a hypothesis, you're going to manufacture some fake data, you're going to write a complete data section with that fake data, and then you're going to write a conclusion that's a little different than usual, because you're going to write a conclusion where you discuss data that refutes your hypothesis. That's like its own paragraph. And then you're going to use data to support your hypothesis, a different set of data that you made up. Okay? Of course, as always, when you're using that data, you've got to use actual numbers, right, with actual units. Now, you're also going to calculate error and do error analysis in a conclusion. So really, you're going to write a complete conclusion here, as well as a complete data section. So, hypothesis, data section, and conclusion. That's what we're shooting for on this Momentum Lab report.